Super excited to be here today and talk about some of the new stuff we have coming in .NET. The talk is a .NET 8 talk, a little bit. I'm going to talk about some of the cloud-native parts of .NET, some of the AI parts of .NET. There's other parts of folks from Microsoft here. Maddie and David from the Maui team are here, and they'll do some presentations as well on Maui. We got Jeff Fritz, and he's doing some presentations on ASP.NET. Thank you for the introduction. I'm Scott Hunter. I'm the VP of Product at Microsoft on our Azure Developer Experience team. And let's get into a couple of .NET things. So we started this vision back in 2014 when we rebooted .NET to basically build a platform for building any type of application. You know, we don't care if you want to build a mobile app, you want to build a web application, a console application. And we wanted to have a unified set of tools, VS and VS Code, or even command line if you're on Linux or a Mac. And then of course we support all the platforms, Windows, Mac, and Linux. And not only do we support those platforms, we support them on x64, x86, ARM32, ARM64. We've done a lot of work in the ARM space the last couple of years. Once we did that reboot in 2014, we're at a point now where we have about 6.1 million developers for a 21-year-old tech, which I'm pretty excited about. We've been growing at a great pace year over year. The most important thing for us is we've taken 53,000 things from the community in open source. So we open sourced in 2014, so we were really late open sourcing. But it's amazing to see that we've had 53,000 people actually contribute to the platform over the last couple of years. .NET's always been in the Stack Overflow Developer Survey. We've always been in the top 1, 2, or 3 for the last couple of years. If you look at the Cloud Native Foundation, which measures the velocity of OSS projects, this is how many issues, PRs, and stuff are actually happening inside of GitHub. We've been in the top 5 for the last couple of years as well. And C# is the number 5 language, the top 5 language in GitHub. Speaking of that, before I even do performance, I'm going to jump to C# and just start with C#. C# 12 ships with .NET 8, and it's got a couple of features that are really cool. I've been focusing on the last couple of years how we actually have less ceremony. Not only do we want to make, you know, I said before, .NET's been around for 21 years. We want to make it as just approachable for a JavaScript customer or a Python customer as it would be for a C++ or Java customer. And so to do that, we've been getting rid of a lot of boilerplate and simplifying our syntax for the last couple of years. I'm going to talk about one huge feature, which is called primary constructors, that I'm going to show, and I'm also going to show what I call collection literals. And these are just ways that we make our language cleaner. And so with that, let me jump over and show some code here. So first off, I'm going to use a tool called sharplab.io. It's a really cool technology that actually takes the code that you see on the left here and shows you what the compiler actually makes for that code. And so one of the things we did a couple of releases ago is, as I said before, we're trying to make .NET more approachable. So we've had, you know, this public class, this main thing. You know, I can get rid of these things. I can just come over here and just do this. We started doing this a couple of releases ago. What's kind of cool about this is when I do that, notice that the compiler still goes and generates that static void main, that class program. I can just write my code. And so this is part of something we shipped around .NET 6, where I don't require anything. I can start writing code inline in the actual application. And I like to show how that actually works. And so this is kind of showing how that works. But let's jump over to my app, and I'm just going to copy and paste a couple things over here. So this is primary constructors. Is one of my favorite features that we have in C# 12. And so what I'll do is I'll just paste this class over here. This is what you would expect. I've got a class, I've got a constructor, it takes some parameters, and all it does is assigns those parameters to the various properties. You've seen this a million times. In C# 12, we can simplify this. And I'll just copy paste it. It's faster than me typing in line here. I can take that and replace it with this. So in this case, I've actually now made the class definition have what we call a primary constructor. It's got the X and the Y's right there. And so I get rid of all that method. And I'll show you in a second why that's important. But what's cool here is if I go and get rid of this, and we go look what the compiler generates, it's going to basically generate the same constructor that we've always had. So once again, this is just making the compiler better and letting you write less code to get your job done. And this really applies, and I'll show you why we did this. We're always sitting around looking at the code that we have, and a really common thing when you're building web applications is, in this case, I'm going to use dependency injection to inject a logger. Almost every ASP.NET web page is going to have this. So you see here, I've got my page, and I've got my private logger variable, and my constructor takes this thing. Every single application, every single web page has this same chunk of code. And so the idea behind primary constructors was, let's just get rid of that. Let's just take this. I can move it right up here. And then I can erase all this junk. What do you think? Is that good? I think that's awesome. So literally this is us looking at our code every day and asking, why do we have the same boilerplate code in all these places? And so this is a thing that we're doing in the product. So let me go switch back to some of the code here. And let's show the new literal tech we have in C# 12. It's okay to save that. So I'll just copy some other stuff here. Just copy a chunk of this stuff, and we'll paste it over here so you can see what actually happens with the compiler. So we've always had this kind of syntax here where I can basically say, hey, I've got an int array, and I'm going to say new int array and feed it some stuff. We've got this new simplified syntax we've had for a while where I can just say int array and just give it the list of parameters, and we'll do all that other stuff for you. And you can actually see down here, if I deleted the code already, but it does the same thing. You can see there it's doing a new int 5. It's initializing the parameters. We've now added that same syntax for collections. So if you look here, I've got my traditional list of int, and I've got my new list of int, and I give it the parameters. But if you look down here for starting with right here, once again, we removed all of that new list int stuff. We can infer that. We know you have a list of int, and you can just give us the parameters. And so this is the continuing evolution of us trying to reduce the amount of boilerplate code you have to write as you write this code. I've got one more cool kind of thing here that we've done as well. Notice that I have two lists, and by the way, if I go look, you're going to see the code does the same thing you would expect. It basically boots up a new list of int. We run that for you, and we just call the methods to add that stuff automatically. We're just doing it's syntactical sugar. We've got this really cool new feature where notice I have list of int f, and then I say .e.d. That basically says take the collection of e 6, 7, 8, 9, 10, and then take d 1, 2, 3, 4, 5, and put them in the array. So I can make these collections. I can actually then assign them in other creative ways as well. And once again, if you look down here, the compiler is doing all kinds of magic to copy those things in. And so these are my two favorite features in C# 12. There's other things that I have in the app that I can point to as well. We can now do aliasing. And so if you look up here, I have just taken my name and turned it into an int32. And so anywhere I want, I can declare a Scott, because I'm Scott. So you got to be able to declare a Scott. So I can decide now that I want to have my own Scott variable here. So that's a cool feature. But that's what's new in C#. Let's jump back and talk about some of the other crazy improvements we have in .NET. Jump back here. So when we decided back in 2014 to kind of reboot .NET, we asked ourselves the question, if you're a Java developer or a Node developer or a Python developer or a Go developer, I don't think Go was actually there yet, but it was close. Why would you choose .NET over any other technology? And we thought we would focus on performance. We already had great tools with the Visual Studio family of tools, and so we really focused on performance. And so you can see here, this is the number of performance improvements we put in the product every release, and you can see it's been growing at a pretty good pace year over year, with 1,250 performance improvements in .NET 8. Stephen Tobe writes these amazing blog posts. I'll have a URL that I'll send you in a second. They're like 30 or 40 pages that explain all the performance improvements that we've made in .NET. The link's at the bottom of the page here. But let's take a look at some of the recent improvements we have in .NET 8. So this is showing the Tech and Power benchmark. That's an open source benchmark run by an independent company. Anybody can contribute their framework or their library to that benchmark. And this is just showing that the Tech and Power JSON benchmark, that's when you have an API that returns some JSON. And if you're looking at and comparing .NET against things like .NET 7, you can see we're 18% faster than .NET 7, so that's a nice improvement. You can see we're twice as fast as Go and a lot faster than Express. Over on the right, this is Tech and Power Fortunes. This is the benchmark that I really care about because it's real. It actually makes database calls. It then takes the data and kind of formats it and returns it in a real usable format. So this is what a real app would actually do. And you can see we have a 24% improvement. This means we're making improvements in our database technology. We're making improvements in all parts of the stack. And you can see it stands very, very well up against things like Go and Express again here. So those are the performance improvements that we have in .NET. You can't miss that we're kind of in this intelligent app wave right now. We have a bunch of tech that we build at Microsoft. Obviously, everybody's heard about ChatGPT. And we have OpenAI inside of Azure. My team and Microsoft, we actually build the OpenAI SDKs for all platforms. So we build them for Java. We ported the OpenAI SDK to Java. We ported it to .NET. We don't do the Python one, but we've also done the JavaScript one. We actually might do a Python one to make authentication easier. But we've also built some other technologies. We have a tech called Semantic Kernel. That's for languages that don't have LangChain support. LangChain is a common LLM tool. It's written in Python. And as a .NET developer, I don't really want to use Python. And so Semantic Kernel is kind of the replacement for that for a .NET customer. With that, let me show a couple demos and a great blog post. So Stephen Tobe, who I was mentioning before, he's got this blog post that I would recommend for anybody, and this is demystifying retrieval augmented generation with .NET. This is literally, if you want to use AI in .NET, this is the blog post. And as I said before, Stephen likes to write lots of text, and so it goes on and on and on and on. Let's jump and show some code and see how we can actually do some of this in the real world. So let me flip over to the AI demos. Sure, we can save that. Okay. And so what I've done is I took his blog post and converted it into a very large app. And we'll start off with just a simple, I want to do a ChatGPT style thing. How much code does that take in .NET? It literally fits on the screen here. So I basically new up a semantic kernel. I give it all the, these are all the API keys, endpoints, and stuff like that. You don't want to see those. I tell it it's okay to actually log it to the console. So this is just boilerplate right here. But notice that the actual loop to do ChatGPT is literally 6 lines of code. We we do a prompt, ask the question, we take your response, we feed it into invoke semantic kernel function async, and it will return the answer. So let's try this real quick. So what I'll do is I'll select number 1. We'll start with the first demo. It'll take a second. It just actually went out and actually authenticated with OpenAI. And I can say, what is .NET? And there you go. It comes back and tells me what .NET is. What is generative AI? And for fun, sometime during this demo, I will blow the computer up. So what I did there is why it blew up is my account doesn't have really good access to OpenAI. I'm only allowed to ask a question about every 4 seconds, and so I typed something too fast and it died. So that might happen again. But that was cool, but there's a challenge there. I should finish one more thing here. Let's go back here. What is the current time? Well, it's going to come back and tell me it doesn't know the time. And that's because ChatGPT is basically based on a model that was built on the internet at a point in time. And so when you ask it a question like this, you can't answer that question. So how would we fix that? Well, it's not very hard to fix that. So we'll switch to the second part of this. I'll minimize this, and I'm going to go to custom function. And so all I've done here is, once again, boilerplate, just initialize the kernel. This time, I want to actually register a custom function. And so I can basically give ChatGPT or give OpenAI as many custom functions as I want. In this case, what I'm going to tell it is, here's a lambda that says, when you call me, I'm going to return the date, time, UTC now, and then I give it a couple of other parameters telling it what it's doing. It's called date time. It's getting the current time, the now time. So I kind of explain what that is, and then I can actually give it some more code here where I can actually tell it how to format and actually answer the question. So this is my input, and this is the output. And so then I'm back in that exact same loop again, except now, if I run this application, I can go and select 2 for date time and say, what is the current time? And now it knows what the current time is. It's actually called my C# code, and this is how you would actually train the AI to do exactly what you want. And it's pretty cool. I can think that's, what day of the week is it? Now it doesn't know that because, well, where am I? I didn't give it enough information to know where I actually am, so what day of the week is it in Boston? And so now it's actually telling me it's Wednesday in Boston, and I can even ask things like, what day will it be in 10 days? Maybe. Yeah. So you can see how that works. Now, let's have some more fun with it. Let's ask, tell me a joke about a dog. Why did the dog go to the vet? Because he was feeling rough. Okay, that in itself is not super cool, but the thing here is I can ask it, why is that joke funny? And I'm sorry, I don't know how to do that. Why does it not know how to do that? Because I really, most of the time if you've actually tried ChatGPT, it's actually reading all the questions you've asked it. And so it's got what I would call memory. And so let's add memory to it now so it can actually do this correctly. Okay, so I love how that keeps coming back every single time. So we will scroll to the next thing. And once again, I think the thing here I think that's really exciting is I'm not writing lots of code. That's the important thing here. Is our goal is to make it easy for you to use this technology in .NET and not have to write a lot of code in the process. And so now, all I've done is I've got that same kernel I always build every single time, except this time I've actually got a chat completion, and I've asked for a chat history. And so all I've done now is notice my chat history. When I ask a question, I then feed that question into the chat history. And then when I go and ask the AI for to get my message, I'm going to pass it that chat history right there. And so not a lot more lines of code here, but when I run it now, that's not the one I want. Let's go to 3. Now it's really making me mad because I didn't change any code. Did I fix it or did I make it worse? I fixed it. Okay. So let's go to memory. Tell me a joke about a dog. And now I can ask, why is that joke funny? I'm just waiting so it doesn't time out. And the joke is funny because it used a play on the words rough. It's a word to sound like rough. And so now my history is actually there. And so that's really cool. Now let's take the next version of this. I'll stop. And we've all seen when we do ChatGPT, it kind of does this kind of streaming thing where it's showing me this nice, cool form where I get that nice streaming response here. And so let's show that now. This version, notice that I actually I'm adding the history like normal, and I'm doing a loop around returning that code back. So we'll run number 4. Write a poem about a dog. You like dogs. And it kind of scrolls in, so now I've got that nice ChatGPT feel to it. It feels like I'm actually talking to something, not just getting an instantaneous response back. That's kind of cool. Now let's ask a question. And it's a fun question. Is the .NET regex backtracking or non-backtracking? And so it says that it's going to use backtracking, and but that's actually not true. We actually have a non